Hi, everyone. So we just talked about how x to the fifth divided by x to the third is x to the second, not 5/3, second. We subtract the exponents. Now, these two expressions are equivalent, except when x is what value? When x is what real number? When x is 0. We never divide by 0. And if you try to divide by x to the third, you're trying to divide by 0. So there is what I call a hidden restriction here. That's not an official term, but I'm going to refer to this a lot. And this comes up a lot when we talk about issues of domain later on in chapter 1. So x to the fifth divided by x to the third, we can do that as long as x takes on any non-zero real value. Then the result is x squared. But in order for these two expressions to be fully equivalent, we should really tie these two things together. X to the fifth divided by x to the third, you should really rewrite that as x squared, but remind us x cannot be 0, because it is not evident from this expression, x squared, that 0 is an illegal value for x. So that's when a restriction is hidden. If it's not clear that restriction applies here. If you look at x squared, it looks all good. It looks like it's good for all real values of x. But because x cannot be 0 back here, we cannot divide by 0. 0 is also illegal for x over here, in order for these two expressions to be truly equivalent. Hidden restrictions, that's going to come out once in a while, especially in chapter 1 when we talk about domain. You should write these down. Granted, in trig, we're often going to forget about them.